Alright guys, welcome back to the channel. Today we're going to be going through a very specific type of question. Okay, this is a differential equation question that was found in the paper we've gone through this week. And it's already on the hardest questions video, so if you haven't already, make sure to check that out. But I wanted to single this one out in particular, alongside the integral question, which I uploaded last week, because it's just very unique, and it was one of the harder questions of this nature. So without further ado guys, let's get right into the video. Alright guys, now for number 7, 7a specifically, it's given that y is equal to ln of ln x, okay? And it wants us to show that from this, that dy by dx is equal to 1 over x ln x, right? So how do we go about doing that? Well, dy by dx, okay, knowing that y is equal to ln of ln x, it's simply just going to equal 1 over ln x. Okay, then you apply the chain rule here. It's ln of ln x, so 1 over ln x times dx of ln x, alright? And what's that going to give you then? Well, that's going to give you 1 over ln x times 1 over x, which equals 1 over x ln x, okay? Simple enough. That's the first bit for 7a. Alright guys, now for number b, we've got the following question. We've got a differential equation x ln x plus t times dx by dt equaling 0, okay? And it's given that x equals e when t equals 2. And knowing that, it wants us to then solve the differential equation, okay, obtaining an expression for x in terms of t, right? So how do we do that? Well, what we're going to say is x ln x, okay, plus t dx plus dt equals 0. Okay, just starting off with that. We can then say, right, we've got t dx by dt here. That's going to equal minus x ln x, right? Which therefore means that dx by dt is equal to negative x ln x, right, over t. Cool. So then, moving on from here, we can then separate the variables even more. We can say that negative 1 over x ln x dx is equal to 1 over t dt, alright? And as a result, we can now integrate, right? We can say that we've got negative integral of 1 over x ln x dx here, and that's going to equal the integral of 1 over t dt over here. Brilliant. Brilliant. Now, interestingly enough, okay, we were told in the beginning that y is equal to ln of ln x, okay? Y is equal to ln of ln x. So I can say, well, now since y is equal to ln of ln x, okay, and we know that dy by dx, right, is equal to 1 over x ln x, we can say, well, therefore, what we've got here is, if we integrate, we're going to get negative ln of ln x, right, being equal to ln t plus c. Now, why have we done that? Because, as you can see, we've integrated this, and we've applied the minus to it. And over here, it's just a simple case of integrating according to our ln rules. So that's ln t, right? And adding the constant of integration. But we're not done yet. Okay, it's given that x equals e when t equals 2. Okay. So now x equals e when t is equal to 2, right? So therefore, negative ln e is going to equal ln 2 plus c, right? And what's ln e? Ln e is 1. So you go negative ln 1 is equal to ln 2 plus c, which means that c is going to give us negative ln 2. So putting this all together now, guys, what we get is therefore ln x is equal to negative ln t plus ln 2. Alright? And we can therefore say that, okay, now this is a part that's going to kind of trip people up a bit, because you've got ln x, what do we do now? Well, think about it like this, right? We can say that ln x, okay, is going to equal e to negative ln t plus ln 2, right? That's going to give me e to negative ln t times by e to ln 2. Alright? Which means that ln x, alright, is going to give me what's going to equal I'm going to have 2, okay, and we're going to have t to the minus 1 according to our exponential rules, okay? Therefore, ln x is equal to 2 over t, so therefore x is equal to e to the power of 2 over t. Okay? And that's going to be the final answer to that question. So just a recap on that, okay? Just a recap on this. We know this, and we've now been asked a differential equation. It wants us to find an expression for x in terms of t. Okay, so we lay out the equation. We then say, okay, we've got negative 1 over x ln x dx is equal to 1 over t dt. And we know that since y, okay, we separate the variables, and we also know that since y is equal to ln of ln x, what that implies, okay, is that this is going to turn into ln of ln x, okay, because this is dy by dx. And then we get this here, apply initial conditions, okay, cool. And then we just simplify from there. Okay, raise everything to e, we get to this, and then we apply the logarithm rules. Alright, and as a result, we get 2 times t to the minus 1, okay, x equals to e to the power of 2 over t.